Hello friends, this video show the type 4 DFA, which is a divisibility problem. Okay, so here we solve a question, and the question is that I have to construct a DFA for all string which is divisible by 3. Okay, so this is a divisibility problem. So in this we take a logic that for the remaining type we have assumed some states. So in this also, in this type also we also use some state. Okay, and that logic is that we use the remainder concept. Okay, we use the remainder concept for assuming the different type of states. For example, if a problem is that I have to construct a DFA for all string which is divisible by 3, then we take that Q0 is an initial state which shows 0 remainder. Okay, then assume next state Q1 which shows 1 remainder. Okay, and Q2 state which shows 2 remainder. So for 3 divisibility problem we take remainder 0 to n minus 1. If n is 3, then we take 0, 1 and 2 remainder, and we assume these 3 0, 1, 2 remainder values as Q0, Q1 and Q2. Now we take input sigma is equals to 0 to 9, 4, 5, 6, 7, 8, 9. Now you can ask one question, that why I take only 0 to 9 as an input value? Why not 10, 11, 12? So for this reason, please go through all the at the end of the video, and while we construct this construct the DFA at the end, you can examine that after 9th value, means 10, 11, 12 and so on, all the values come while taking only these 0 to 9 values. Okay, so in this case the main important point is, for in the divisibility problem there is no final state. Okay, now for these assumptions and by these input we construct the transition table. Okay, and for constructing the transition table we take Q0 as 0 remainder, Q1 as 1 remainder and Q2 as 2 remainder. Now for here we always write down the input values, but if I take 0 to 9 values separately, then it shows very complex. So I combine all those values which gives the same remainder while divisible by 3. For example, from 0 to 9, if I combine 0, 3, 6 and 9, and all these four value while divisible by 3, it always gives 0 remainder. So we combine all those value which gives the same remainder. Okay, now the next combination is 1, 4 and 7. Means if 1, 4, 7 is divisible by 3, it always gives 1 remainder. Okay, and the last combination is 2, 5 and 8. Okay, now for this entry I have to combine 0 with any one of these input. First of all, if I combine 0 and this 0, 0 and this 0, and I divide by 3, it gives 0 remainder. Okay, it gives 0 remainder, and for 0 remainder we assume that 0 remainder the state is Q0. So this entry will be Q0. Or if I combine 0 to 3, 0 with 3 and I divide by 3, then the remainder again will be 0. So if you combine 0 with any of these values, it always gives a 0 remainder, and that this Q0 state remains the same. Okay. Now for this entry, I have to combine 0 with any value 1, 4, 7. So if I combine 0 with 1 and I divide by 3, it always gives 1 remainder, which is a Q1 state. So this entry will be Q1. Okay. Now I combine next value 0 with 2 and I divide by 3. It always gives 2 remainder, which is a Q2 entry. So this entry will be Q2. Okay. Now for this entry, I have to combine 1 with 0. So it will become 10. So why? So this is the answer, that why we take only 0 to 9 values, not after 10, not after 9. Because this 10 value, or you can say after 9th value, 10, 11, 2, if I combine 1 by 1 values, all those values come defaultly. For example, if I combine 1 and 0 or 1 by 1 and 3, so it will be, the number is 13. 1 and 6, 16. 1, 9, 19. So if I combine 1 with 0 or 1 with 3, 1 with 6, 1 with 9, and if I divide with 3, it always give 0 remainder, which is it will always give 1 remainder, which is a Q1 entry. So here the entry will be Q1. Now if I combine 1 with 1, means 11, and I divide with 3, it gives 2 remainder, which is a Q2 entry. Okay. Now the next value is, I combine 1 and 2, that is 12 divided by 3, and it will give 0 remainder, which is a Q0 value. Okay. Now I have to combine 2 with 0, that is 20, and if I divide with 3, it gives 2 remainder. So the entry will be Q2. If I combine 2 with 1 and I divide by 3, it gives 0 remainder, which is a Q0 entry. Then if I combine with 2, and I divide by 3, 2, it gives 1 remainder, and this entry will be Q1. So this is how we create this transition table, and by using this transition table, now I create the DFA. Q0, which is the initial state, Q1 and Q2. Now for Q0, if I give 0, 3, 6 and 9 as an input, the state remains the same. So I will create a self loop and put an input as 0, 3, 6 and 9. Okay. Now for Q0, if I give 1, 4, 7 as an input, the state will change and it will become Q1. Means for this entry 1, 4 and 7. Okay. Now for Q0 2, 5, 8, the state will be Q2. So this entry will be 2, 5 and 8. Okay. Now for Q1, if the input is 0, 3, 6, 9, the state remains the same. So for Q1, here we create a self loop and the entry will be 0, 3, 6 and 9. Okay. Now for Q1, if the input is 1, 4, 7, then the state will be Q2. So from Q1, if the input is 1, 4, 7, the state will change and it will become Q2. Now from Q1, if I put the input 2, 5, 8, the next state is Q0. It means from Q1, okay, and if I put the entry 2, 5, 8, the state will change and it will move to Q0. Okay. Now for Q2, for input 0, 3, 6, 9, the state remains the same and the input will be 0, 3, 6, 9. For 1, 4, 7, for Q2, the state will change and it move to Q0. So I will show like this, and the input will be 1, 4, 7. And for Q2, and if the input is 2, 5, 8, it moves to Q1 state and the input is 2, 5, 8. So this is how we create a DFA for a divisibility problem. And if you like our video, then please subscribe our channel and share or like our videos. And if you have any doubt, then you can please ask anytime by placing your doubts in our comment box.